Hello everyone. In this example, we're going to see a very simple circuit that includes a single resistor, and we will be able to calculate the current that flows through it by applying Ohm's law. So let's go into that. This is a simple circuit that includes one DC voltage supply of 5 volts, and it includes a resistance R, and we're going to assume that we have a way to control this resistance from 0.5 ohms, 5 ohms, and even infinite ohms. In each one of those cases, we would like to calculate the resulting current through this resistance and, of course, through the loop. So really, the mechanics here are very simple. We can go ahead and apply Ohm's law, and Ohm's law says that I will be equal to the voltage that you apply divided by the resistance R, provided that we have the passive sign convention. Now, do we have passive sign convention? Yes, indeed. The current I flows through the resistance from plus to minus, so I can go ahead and apply Ohm's law. So for the first case, when my resistance R is half an ohm, I can write down that this is equal to 5 volts divided by 0.5 ohms, and that will yield a current of 10 amps. Moving on, in the second case, this will be equal to 5 volts again, but now this is divided by 5 ohms, and therefore the current I will be equal to 1 amp. And finally, when my resistance is really infinite, it basically doesn't matter how high my voltage is. 5 volts divided by infinity ohms will basically give me 0 current, as it should be the case. And infinite resistance practically means an open circuit. Now, let me also take one more step here and very quickly calculate, at least for the first case, what is the conductance of that resistance. We have seen that the conductance G is basically defined as 1 by R. So since my R here in the first case is half an ohm, the conductance G is going to be equal to 2 Siemens. And in a very similar way, you can calculate for all of them, including the very last one, where for the last one, the conductance G will be equal basically to 0 Siemens. That's 1 divided by infinity ohms. Essentially, it means there is really no conductance in that case. So this concludes the example I want to show you here. It's a very simple application of Ohm's law. Biggest thing I want to remind you is that I is equal V by R, provided that you're in the passive sign convention. So thank you very much. We will see you in the next video.